This is the IFR 1200 with Spectrum Analyzer, and now we're going to take a look at the modulation capabilities of the monitor, at least a little bit. First of all, let's take a look here. We can turn on the generate. We can see that it's got a nice spike on the Spectrum Analyzer. We can turn on some modulation. You can see that it does good modulation. It's a little bit high for that channel. Alright, now another thing we can do on the IFR is we can switch it over to something called duplex generate. And in this situation, the signal comes out of the duplex port while we are simultaneously receiving at the antenna port. And for our test, the first thing we need to do is make sure the offset is set to 0. It is. Now the offset can be up to 49.9 megahertz in either direction, although I've seen that this monitor will actually go a little bit further than that. We set it to the duplex. We've got it set up for 0 offset, and now we're going to take the output from the duplex port and pipe it right back into the antenna port. As you can see, there's a signal there. Now if we throw on some modulation there, it's the same thing we saw before. 5 kilohertz of deviation. And an interesting thing we can do is we can use modulation index, which I believe is derived from something called the Bessel function. But in either case, you take the frequency of the modulating signal at a particular deviation will cause our carrier to null out to 0. All of the power ends up in the sidebands. And that's very useful for checking the modulation calibration on our meters. So let's go ahead and do that. For 5 kilohertz deviation, or for a total of 5 kilohertz on the modulation meter, what we're going to do is we're going to modulate that with a tone of 2074.7. Oops, kind of missed that, didn't I? Let's try again. 2074.7. Okay, we're going to want that in a sine wave. Just change that. Okay, well that's close enough. The function is very, very broad on the frequency here. So let's go ahead and turn that on, and we'll switch that over so we can see the waveform. And as we increase the modulation, you can see that the carrier begins to drop out and it reaches a null right there. And at that point, all of the energy is in the sidebands rather than in the carrier. And we can switch our monitor over, take a look at the meters, and we can see that that's 4.95 on the meter, which means that the monitor is very, very close. It's almost impossible to get the monitor to completely null that out because the adjustment is so critical when it gets very close to the null point. But this is a good way to check and verify that 5 kilohertz deviation on our modulation meter and here is verified by that tone 2074, which again is derived from the modulation index, or also called the Bessel function. So here we go. This monitor is well calibrated.